Lesson 14. Differentiation of Trigonometric, Logarithmic, and Exponential Functions. Hello everyone, I'm Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from me. Let's start with differentiation of trigonometric functions. We will begin with differentiation of simple trigonometric functions, which are sine x, cosine x, and tangent x. So the basics are, first we need to know the differentiation of sine x. The differentiation of sine x in terms of x equals cosine x. And the differentiation of cosine x in terms of x is negative sine x. So these two are the very basic differentiation of trigonometric functions, and please memorize it. Next, let's talk about differentiation of tangent. So we need to use Quotient Rule. So now let's see. Differentiation of tangent in terms of x will be equals differentiation of sine x over cosine x in terms of x. Remember, tangent x equals sine x over cosine x. Then from here, we identify u as sine x, v as cosine x. Therefore, du over dx equals cosine x, and dv over dx equals sine x. Why is it so? Remember, we have just covered, right? When I want to differentiate sine x, it is equals cosine x. When I want to differentiate cosine x, it is equals negative sine x. Now, apply quotient rule, which is d over dx, u over v equals v du over dx minus u dv over dx over v squared. Hence, let's go back to differentiation of sine x over cosine x in terms of x. It will be equals cosine x times cosine x minus sine x times negative sine x over cosine square x. So we combine and expand, and we get sine square x plus cosine square x plus sine square x over cosine square x. Remember the identities, right? Cosine square x plus sine square x equals to 1. Therefore, it becomes 1 over cosine square x, which means that d over dx of tangent x equals secant square x. So please remember this as well. Next, let's look at differentiation of Trigo with power. Here are the steps. Step 1, bring down the power. Step 2, copy Trigo and power minus 1. Step 3, differentiate Trigo. So let's look at the basic Trigos here. First, differentiation of sine to the power nx. So it is equals, remember the step, we bring down the power, which is n. Then the power minus 1, so it will be sine x to the power of n minus 1. Then we differentiate the Trigo. So differentiate sine x, we get cosine x. Now from here, if n equals 2, then differentiation of sine square x in terms of x equals 2 sine x cosine x, which means that differentiation of sine square x equals sine 2x. So next, let's talk about differentiation of cosine to the power nx in terms of x. So repeat the same step. Bring down the power, which is n. Then power minus 1, so cosine x to the power n minus 1. And differentiate Trigo, we get negative sine x. So we can rearrange this negative n cosine to the power n minus 1 x sine x. So if n equals to 2, then d over dx cosine square x equals negative 2 cosine x sine x, which means differentiation of cosine square x in terms of x equals negative sine 2x. Now, let's talk about differentiation of tangent to the power nx. In the same step, bring down the power minus 1, so tangent to the power of n minus 1, and then differentiate tangent x, we get secant square x. If n equals to 2, then differentiation of tangent square x in terms of x equals 2 tangent x secant square x. So please remember these formulas. Now, let's talk about the differentiation of the reciprocals. So d over dx of secant x equals, we can rewrite it to become d over dx cosine x to the power of negative 1. Then we can repeat the same steps, power bring down, so equals negative 1. Copy the Trigo and power minus 1, so it becomes cosine x to the power of negative 2. And differentiate the Trigo, so we differentiate cosine, we get negative sine x. Then we can rewrite this equation becomes 1 over cosine square x times sine x, or it is equals 1 over cosine x times sine x over cosine x, which means differentiation of secant x in terms of x equals secant x tangent x. Next, differentiation of cosecant x over dx. We can rewrite this into differentiation of sine x to the power of negative 1 over dx. Then we repeat the same process, power bring down, which is negative 1. Copy Trigo, sine x, and power minus 1, so it becomes to the power of negative 2. Now we differentiate the Trigo, so we differentiate sine x, we get cosine x. Then we can rewrite it becomes negative 1 over sine square x cosine x, or negative 1 over sine x times cosine x over sine x. And we can say that differentiation of cosecant x equals negative cosecant x cotangent x. Next, to differentiate cotangent x in terms of x, we can rewrite it to be differentiation of tangent x to the power of negative 1 over dx. So now repeat the same steps, bring down the power, so power is negative 1. Copy Trigo and power minus 1, so tangent x to the power of negative 2. Differentiate tangent x, we get secant square x. So rewrite this equation, it is equals negative cosine x over sine x square times 1 over cosine x square. So now we open the bracket, we get negative cosine square x over sine square x times 1 over cosine square x. Then we can cancel the cosine square x, we get negative 1 over sine square x, which means differentiation of cotangent x in terms of x equals negative cosecant square x. The third differentiation of trigonometric functions that we need to talk about is the differentiation of sine bracket ax plus b, cosine bracket ax plus b, and tangent bracket ax plus b. So here are the general steps. Step number 1, differentiate the Trigo. Step number 2, differentiate the bracket. So let's see one by one. First, differentiation of sine ax plus b in terms of x equals cosine ax plus b followed by a. Or we can rewrite it becomes a cosine ax plus b. Number 2, differentiation of cosine ax plus b in terms of x equals negative sine ax plus b, which is the first step, differentiation of the Trigo. Then step number 2, differentiate the bracket, which we get a. So we can rewrite it becomes negative a sine ax plus b. Number 3, differentiation of tangent ax plus b. So repeat the same step. Step 1, differentiate the Trigo, so tangent becomes secant square ax plus b, followed by differentiate the bracket, we get a. So we can rewrite the equation becomes a secant square ax plus b. Next, number 4, differentiation of sine to the power of n bracket ax plus b, cosine to the power of n bracket ax plus b, and tangent to the power of n ax plus b. Here are the steps. Step number 1, bring down the power. Step number 2, copy Trigo and the power minus 1. Step number 3, differentiate the Trigo. Step number 4, differentiate the bracket. So let's see the differentiation one by one. So I want to differentiate sine to the power n ax plus b. Then bring down the power, so it is n. Then copy the Trigo and the power minus 1, so it becomes sine to the power n minus 1 ax plus b. Then we differentiate the Trigo, so differentiate sine, we get cosine ax plus b. And we differentiate the bracket, so differentiate ax, we get a, differentiate b, we get 0. So we rewrite, it becomes an sine to the power of n minus 1 ax plus b cosine ax plus b. 2. Differentiation of cosine to the power of n ax plus b. So the step is bring down the power, so it's n. Copy the Trigo and power minus 1, so it becomes cosine to the power of n minus 1 ax plus b. Differentiate the Trigo, so differentiate cosine, we get negative sine ax plus b. And then differentiate the bracket, we get a. Rewrite it, it becomes negative an cosine to the power n minus 1 ax plus b sine ax plus b. Number 3, differentiation of tangent to the power n ax plus b. So bring down the power, which is n. Copy the Trigo and power minus 1, so it's tangent to the power n minus 1 ax plus b. Differentiate the Trigo, we differentiate tangent, we get secant square ax plus b. Then differentiate the bracket, we get a. Rewrite this everything, right? We get a n times tangent to the power n minus 1 ax plus b secant square ax plus b. In general, differentiation of sine to the power n fx, cosine to the power n fx, and tangent to the power n fx. Here are the steps. Step 1, bring down the power. Step 2, copy the Trigo and power minus 1. Step 3, differentiate Trigo. And step 4, differentiate the bracket. So let's see the differentiation one by one. First, d over dx of sine to the power n fx equals, so step 1, bring down the power, which is n. Step 2, copy Trigo and power minus 1, so we get sine to the power n minus 1 fx. Then differentiate Trigo, we differentiate sine, we get cosine fx. And differentiate the bracket, so the bracket is fx, then we get f prime x. So number 2, differentiation of cosine to the power n fx. So we repeat the same step. Bring down the power is n. Copy Trigo and power minus 1, so you get cosine to the power n minus 1 fx. Then differentiate the Trigo, we differentiate cosine, we get negative sine fx. And differentiate the bracket, which we get f prime x. We can rewrite it, it becomes negative n cosine to the power n minus 1 fx sine fx f prime x. Number 3, differentiation of tangent to the power n fx in terms of x, we get power bring down, which is n. Copy the Trigo and power minus 1, so it's tangent to the power n minus 1 fx. Differentiate the Trigo, so we differentiate tangent, we get secant square fx. And we differentiate the bracket, which is f prime x. Now, let's see some examples how to differentiate trigonometric functions. Here is the example. Differentiate the following with respect to x. A, 2 cosine 4x plus 1. B, tangent cube 4 minus 2x. C, x squared sine pi x over 3. Here is the solution. For A, d over dx 2 cosine 4x plus 1 equals, so the constant we copy, and now we differentiate the Trigo, differentiate cosine, we get negative sine 4x plus 1. Then we differentiate the bracket, so 4x plus 1 becomes 4. Rewrite the equation, we get negative 8 sine 4x plus 1. For b, d over dx tangent cube 4 minus 2x equals, step 1, bring down the power, so we get 3. Step 2, copy Trigo and power minus 1, so we get tangent square 4 minus 2x. Then we differentiate the Trigo, so we differentiate tangent, we get second square 4 minus 2x. Then we differentiate the bracket, we get negative 2. Then we rewrite the equation, you get negative 6 tangent square 4 minus 2x, second square 4 minus 2x. C, we need to apply product rule. First, we need to identify u as x squared, v as sine pi x over 3. So du over dx equals 2x, dv over dx equals cosine pi x over 3 times pi over 3, or pi over 3 cosine pi x over 3. Hence, d over dx x squared sine pi x over 3 equals x squared pi over 3 cosine pi x over 3 plus sine pi x over 3 times 2x. So rewrite the equation, we get pi over 3 x squared cosine pi x over 3 plus 2x sine pi x over 3. Okay, now you can try this example yourself. Differentiate the following with respect to x. A, square root of tangent 8x minus 3. B, cosine to the power 4 9 minus 2x squared. C, sine 2x over 2 minus cosine x. You can pause the video and try to solve it yourself. Here is the solution. For A, d over dx square root of tangent 8x minus 3, we have to change it into the indices form. Then we get d over dx tangent 8x minus 3 to the power half. Then power bring down, which is half. Copy the Trigo and power minus 1. Then we get tangent 8x minus 3 to the power of negative half. Then differentiate the Trigo, so we differentiate tangent, we get second square 8x minus 3. Then we differentiate the bracket, we get 8. Now we can rewrite the equation. So 2 and 8 cancel, we get a 4 here. So the equation becomes 4 second square 8x minus 3 over square root of tangent 8x minus 3. B, so d over dx cosine to the power 4 9 minus 2x squared equals, so power bring down, copy the Trigo and power minus 1, so cosine cube 9 minus 2x squared. Then we differentiate the Trigo, so differentiate cosine, we get negative sine 9 minus 2x squared. Then we differentiate the bracket, so we differentiate 9 minus 2x squared, we get negative 4x. Now we can rewrite the equation, it becomes 16x cosine cube 9 minus 2x squared sine 9 minus 2x squared. Here is the solution for C. We need to apply Quotient Rule. So we can identify u as sine 2x, v as 2 minus cosine x. So du over dx equals cosine 2x times 2, which is 2 cosine x. dv over dx equals sine x. Now, d over dx sine 2x over 2 minus cosine x. When you apply quotient rule, it is v du over dx minus u dv over dx over v squared. So the v is 2 minus cosine x. The du over dx is 2 cosine 2x minus the u is sine 2x. And dv over dx is sine x over 2 minus cosine x squared. Then we expand the bracket, we get 4 cosine 2x minus 2 cosine x cosine 2x minus sine 2x sine x over 2 minus cosine x squared. This is the answer for C. Now, let's apply the techniques of differentiation of trigonometric functions into trigonometric problems. Here is one example. Given that y equals cosine x over sine x minus 2. 1. Show that dy over dx can be expressed in the form p plus q sine x over sine x minus 2 square, stating the value of p and q. 2. Hence, find the values of x between 0 and 2 pi for which y has a stationary value. Here is the solution. For number 1, given the equation y equals cosine x over sine x minus 2, so from here we can apply quotient rule. But first we have to identify what is the u and what is the v. So the u is cosine x and the v is sine x minus 2. So now we want to differentiate dy over dx. We apply the quotient rule, which is v du over dx minus u dv over dx over v squared. So now the v is sine x minus 2, then du over dx, which we get negative sine x, minus u, which is cosine x, and dv over dx, we get cosine x, over v squared. So it's sine x minus 2 squared. So from here, now we can expand and simplify. We get negative sine square x plus 2 sine x minus cosine square x. So minus sine square x minus cosine square x, we get negative 1. So we get 2 sine x minus 1 over sine x minus 2 square. Now we compare this and the form that is given. So we can say that p equals to negative 1 and q equals to 2. Number 2. So given that it is a stationary, so we can let dy over dx equals to 0, which means 2 sine x minus 1 over sine x minus 2 square equals to 0. Okay, so which means that the numerator 2 sine x minus 1 equals 0. We can solve this equation. So sine x equals to half. So the basic angle is pi over 6. Sine is positive, so it is in the first and the second quadrant. Therefore, x equals pi over 6 or pi over 6, which is x equals pi over 6 and 5 pi over 6. Alright, let's try this example yourself. The variables x and y are connected by the equation y equals 3x over tangent 2x. Given that x is increasing at a rate of 3 units per second, find the rate of decrease of y when x equals pi over 8. You can pause the video and try to solve it yourself. Okay, here's the solution. Let's look at the question first. So it is given the equation of the function, which is this one, y equals 3x over tangent 2x. And the question tells us that x increases at the rate of 3 units per second. So this is a constant rate. And we can say that this is dx over dt. And they want us to find the rate of decrease of y. So in other words, right, when you want to find the rate of decrease of y, the dy over dt will be a negative value. Okay, so now let's look at the equation given, y equals 3x over tangent 2x. So from here, we need to use the quotient rule. Then we need to identify that the u is 3x and the v is tangent 2x. So now, apply the quotient rule, dy over dx, right, which is v du over dx minus u dv over dx over v squared. So the v is tangent 2x, then du over dt, du over dx is 3, minus u 3x, then dv over dx will be second square 2x times 2 over v squared, so it will be tangent 2x squared. From here, we can simplify, it becomes 3 tangent 2x minus 6x secant squared 2x over tangent squared 2x. So after that, we have dy over dx and also dx over dt, which is given 3 units per second. Then we can apply the chain rule. Dy over dt equals dy over dx times dx over dt, which equals 3 tangent 2x minus 6x secant squared 2x over tangent squared 2x times 3. So given that x equals pi over 8, so we can substitute x equals to pi over 8 into dy over dt, which becomes 3 tangent 2 times pi over 8 minus 6 times pi over 8 secant squared times secant squared 2 times pi over 8 over tangent squared 2 times pi over 8 times 3. So we will get a value which is 3 times 1 minus 3 pi over 4 sub2 square over 1 times 3, and we get the value is negative 5.14 units per second, nearest to 3 significant figures. Okay, so as expected, it is a rate of decrease, then we get a negative value of dy over dt, and we can say that y decreases at the rate of 5.14 units per second. Next, let's talk about the differentiation of logarithmic functions. Here are a few important formula. Usually, we start with ln x, so d over dx ln x equals 1 over x. In general, d over dx ln fx equals f prime x over fx. If the ln bracket ax plus b, we want to differentiate it, so we get d over dx ln ax plus b equals a over ax plus b, because when we differentiate ax plus b, we get a, and the ax plus b we just put at the bottom, so we get ax plus b. If we put it into the more general terms in logarithmic functions, so d over dx log ax equals 1 over x ln a. In more general term, if you want to differentiate log a fx, so d over dx log a fx, it is equal f prime x over fx ln a. So let's say d over dx log a, ax plus b, it is equals a over bracket ax plus b ln a. Now let's see example on how to differentiate logarithmic functions. Here is the example. Differentiate the following with respect to x. A. Ln 5x minus 2. B. Ln square root of 4x squared plus 3. C. Ln 3x squared over 2x minus 1. Here is the solution. For A, d over dx ln 5x minus 2. So we just apply the formula. We differentiate 5x minus 2, we get 5. So put at the top. Then 5x minus 2 just write as the numerator. So the answer is 5 over 5x minus 2. For B, d over dx ln 4x squared plus 3 to the power of half. So notice that I put it in the index form so that I can differentiate it easily. But remember that for the laws of logarithm, the power half we can bring down, then it becomes d over dx half ln 4x squared plus 3. And we can exclude the constant half. We just need to focus on differentiating ln 4x squared plus 3. So the formula is the 4x plus 3, we put it at the bottom as the denominator. Then we differentiate 4x squared, we get 8x, differentiate 3, we get 0. So the result of the differentiation of 4x squared plus 3, we put it as numerator. Then we can further simplify, it gets 4x over 4x squared plus 3. C. d over dx ln 3x squared over 2x minus 1. So for this case, we also need to apply the laws of indices. So division means it is minus. So we can rewrite it becomes d over dx ln 3x squared minus ln 2x minus 1. Then we can differentiate them separately. Okay, so now for differentiation of ln 3x squared, so the 3x squared, we put it at the bottom. We differentiate 3x squared, we get 6x, then we put it at the top. Now, the second part is the 2x minus 1. We put it at the bottom here. We differentiate 2x minus 1, we get 2. So we put it at the top here. Okay, now from here, we can simplify. We get 2 over x minus 2 over 2x minus 1. So, put them together. It is 2 bracket 2x minus 1 minus 2x over x bracket 2x minus 1. We expand, we get 4x minus 2 minus 2x over x bracket 2x minus 1. And you get 2x minus 2 over x 2x minus 1. We can factorize the 2, so it becomes 2 bracket x minus 1 over x 2x minus 1. Now, you can try this example yourself. Differentiate the following with respect to x. A. Ln bracket 5 minus 2 over 3x. B. Ln 4 minus x squared. C. Ln 4x squared minus 3x plus 1 squared. D. Ln square root of 5x squared minus 1. E. Ln 1 over 3x minus 5 cubed. And F. Ln 5x minus 3 over 3x plus 7. You can pause the video and try to solve it yourself. So here is the solution. For A, d over dx ln 5 minus 2 over 3x. Okay, so we just apply the formula. Inside the bracket, 5 minus 2 over 3x, we put it as the denominator of the fraction. Then we differentiate 5 minus 2 over 3x, it becomes negative 2 over 3. From here, we can simplify, right, by multiplying negative 3 for the numerator and the denominator. I get 2 over 2x minus 15. For B, we can write d over dx ln 4 minus x squared. So again, repeat the same process. 4 minus x squared, we put at the denominator. Then we differentiate 4 minus x squared, we get negative 2x. So we put it as the numerator. Okay, we can swap the sign. It becomes 2x over x squared minus 4. For C, d over dx ln 4x squared minus 3x plus 1 squared. So we can apply the laws of logarithm. So we can bring down the power square there. Becomes d over dx 2 ln 4x squared minus 3x plus 1. So the result will be 2 bracket. So the 4x squared minus 3x plus 1, put it as the denominator at the bottom. Then we differentiate 4x squared minus 3x plus 1, it becomes 8x minus 3. So we put 8x minus 3 as the numerator. Then we expand, we get 16x minus 6 over 4x squared minus 3x plus 1. So this is the solution for D. D over dx ln square root of 5x squared minus 1. So we put it in the indices form. We get d over dx ln 5x squared minus 1 to the power of half. By applying the logarithm law, it becomes d over dx half ln 5x squared minus 1. Now we can apply the formula. So the 5x squared minus 1, we put it as the denominator at the bottom. Then we differentiate 5x squared minus 1, it becomes 10x. Then we put it as the numerator at the top. Then we expand the bracket, we get 5x over 5x squared minus 1. For E, d over dx ln 1 over 3x minus 5 cube. We have to rewrite the equation and put it in the indices form. It is d over dx ln bracket 3x minus 5 to the power of negative 3. So we apply the logarithm law. We can bring down the power. It is d over dx negative 3 ln 3x minus 5. And now we can differentiate the ln. So 3x minus 5, we put it at the bottom, the denominator, and we differentiate 3x minus 5, we get 3. So we put it at the top, the numerator. Then we expand, we get negative 9 over 3x minus 5. For f, d over dx ln 5x minus 3 over 3x plus 7. So we can apply the laws of logarithm. So it is division. We can change it to minus. So it becomes d over dx ln 5x minus 3 minus ln 3x plus 7. Then we can differentiate one by one. So differentiate ln 5x minus 3, we get 5 over 5x minus 3 minus differentiate ln 3x plus 7. Then we get 3 over 3x plus 7. Then we can combine them together, so it becomes 5 bracket 3x plus 7 minus 3 bracket 5x minus 3 over 5x minus 3 times 3x plus 7. Expand. We get 15x plus 35 minus 15x plus 9 over 5x minus 3, 3x plus 7. And the answer is 44 over 5x minus 3 times 3x plus 7. Now, let's learn the application of differentiation of logarithmic functions. Here is the example. Find the coordinates of the point on the curve y equals ln 5 minus 2x at which the tangent is perpendicular to the line 2y minus x equals 3. Here is the solution. Given the equation y equals ln 5 minus 2x, we can find the dy of dx, which is equals negative 2 over 5 minus 2x. How do we get this differentiation? Remember, when we want to differentiate the ln, it is a fraction. The denominator is the function inside the bracket here, so 5 minus 2x, and the numerator is the differentiation of the function inside the bracket, which we get a negative 2. Or we can rewrite it to becomes 2 over 2x minus 5, so that we can write this dy dx easier in the next steps. Okay, so from the line given 2y minus x equals 3, we can make y the subject, which becomes y equals half x plus 3 over 2. So the gradient of the line is equals half. So this tangent is perpendicular to the line. Therefore, dy of dx will be equals negative 1 over the gradient of the line, m line, which is 2 over 2x minus 5 equals negative 2. From here, we can solve this equation. We get 2 equals negative 4x plus 10. 4x equals 8. Hence, x equals 2. Now, we substitute the value of x inside the equation. So, y equals ln bracket 5 minus 2 times 2, which is 4. We get ln 1, which is 0. Therefore, the coordinates of the point is 2, 0. This is the answer for this example. Now, you can try this example yourself. Find the coordinates of the stationary point of the curve y equals x ln x. Leave your answer in exact form. Show your working clearly. Determine the nature of this stationary point. You can pause the video and try to solve it yourself. Here is the solution. Given the equation y equals x ln x, from here we can see that there are two functions multiplied together, which is x and ln x. Hence, we want to differentiate this equation. we should apply product rule, where u is x and v is ln x. Therefore, dy over dx is u dv over dx plus v du over dx. So our u will be x, so dv over dx will be 1 over x. Okay, then our v is ln x and du over dx is 1. So we don't write here. Simplify, we get 1 plus ln x. Next, it is given that it is a stationary point. Therefore, dy over dx equals 0, which means 1 plus ln x equals 0. We solve this equation and we get x equals 1 over e. Then, substitute x equals 1 over e into the equation of the curve. We get y equals 1 over e times ln 1 over e, which we get y equals negative 1 over e. Hence, the coordinates of the stationary point will be 1 over e, negative 1 over e. So, to determine the nature of the stationary point, we apply the second derivative, where d squared y over dx squared equals 1 over x. So, when x equals 1 over e, we don't have to find the exact value of d squared y over dx squared. But from here, 1 over e is a positive number. When you substitute inside d squared y over dx, d squared y over dx squared, which is 1 over x, we get a positive number. So d squared y over dx squared is greater than 0. Hence, we can say that it is a minimum point. So this is the answer for this example. Do you get it correctly? Now, let's see how we can differentiate exponential functions. Here is the basic technique. D over dx, e to the power of x equals e to the power of x. Yes, that's right. When we differentiate e to the power of x, there is no change for the whole function. It still stays the same, e to the power of x. Okay, now if the power is a linear function, which is d over dx e to the power of ax plus b. So what we can do is we just copy the same e to the power of ax plus b here, and then we differentiate the linear function ax plus b, we get a. So from here we can put them together, which equals a e to the power of ax plus b. In general, when the power is a certain function, hence when we want to differentiate d over dx e to the power of fx, we just copy exactly the same e to the power of fx, then we multiply by the differentiation of the function fx, and we get f prime x. So the differentiation of exponential function, body doesn't have to be the natural number, it can be any number, ax. So d over dx a to the power of x equals a to the power of x ln a. So if the power is a linear function, so d over dx a to the power of px plus q will be equals, we just copy the same a to the power of px plus q times with ln a, and then we differentiate px plus q, which we get p. Then we can put together, it becomes p a to the power of px plus q ln a. Now let's put it into more general term. So d over dx a to the power of fx, now the power is a certain function fx. So now when we want to differentiate it, we just copy exactly the same a to the power of fx, then ln a, followed by multiply the differentiation of fx, then we get f prime x. This is the differentiation of exponential functions. Now, let's see some examples that we can apply the differentiation of exponential functions. Here is the example. Differentiate the following with respect to x. A. E to the power 1 minus 3x. B. E to the power of sine 3x. C. X e to the power of x squared. Here is the solution. For A, d over dx e to the power of 1 minus 3x. Okay, remember how we can differentiate it? So we just copy e to the power of 1 minus 3x, then we differentiate the linear function 1 minus 3x, and we get negative 3. So put them together, we get negative 3 e to the power of 1 minus 3x. Similar for B, d over dx e to the power of sine 3x. So we just need to copy e to the power of sine 3x multiplied by differentiation of sine 3x, then we get cosine 3x, and then we differentiate 3x, we get 3. Okay, then we put together, it becomes 3e to the power of sine 3x cosine 3x. For C, so we can see that actually there are two expressions multiplied together or two functions multiplied together. We have to use product rule. So the u will be the x, the v will be e to the power of x squared. So du over dx will be 1, dv over dx will be e to the power of x squared times 2x, which is 2x e to the power of x squared. Hence, d over dx x e to the power of x squared equals x 2x e to the power of x squared plus e to the power of x squared times 1. And we simplify, the answer will be 2x squared e to the power of x squared plus e to the power of x squared. Then we can factorize e to the power of x squared bracket 2x squared plus 1. Hence, this is the answer for C. Now, let's try this example yourself. Differentiate the following with respect to x. A. 5e to the power of x over 2 minus 1. B. 3e to the power of 2x squared minus 3x minus 4. C. E to the power of 2x minus 3 times e to the power of 1 minus x over e to the power of 2 minus 3x. D. E to the power of 2x minus 3 minus e to the power of 1 minus x over e to the power of 2 minus 3x. E. E to the power of 2x minus 3 over e to the power of 2 minus 3x minus e to the power of 1 minus x. You can pause the video and try to solve it yourself. Okay, here is the solution. For A, d over dx 5e to the power of x over 2 minus 1 equals, first just copy 5e to the power of x over 2 minus 1, then multiply with the differentiation of the linear function at the power, we get half. Hence, put together, we get 5 over 2 e to the power of x over 2 minus 1. So similar for B, differentiation of dx 3e to the power of 2x squared minus 3x minus 4. So what we do is we copy exactly the same function here, 3e to the power of 2x squared minus 3x minus 4 times with the differentiation of the power, which we get 4x minus 3. Put them together, we get 3 bracket 4x minus 3 e to the power of 2x squared minus 3x minus 4. For C, d over dx e to the power of 2x minus 3 times e to the power of 1 minus x over e to the power of 2 minus 3x. Maybe you might think of applying Quotient Rule, but actually when you look at it closely, you don't have to apply Quotient Rule. You can use the laws of indices to simplify the function first before you differentiate. So here is what you get. For the laws of indices, we know that a to the power of m times a to the power of n equals a to the power of m plus n, and a to the power of m divided by a to the power of n equals a to the power of m minus n. Therefore, when you see multiply and division, also all the bodies are the same. So when multiply, the power can add together, and division, the power you can minus. So this is what you get. d over dx e to the power of 2x minus 3 plus 1 minus x minus 2x plus 3. Simplify the power, you get d over dx e to the power of 4x minus 4. And now you can start to differentiate. So copy the function here e to the power of 4x minus 4 and then times with the differentiation of the power, which is 4. So the answer will be 4 e to the power of 4 bracket x minus 1. How about D? So again, when you look at it closely, you might think of applying quotient rule. But for this case, you still don't have to apply quotient rule. So now d over dx e to the power of 2x minus 3 minus e to the power of 1 minus x over e to the power of 2 minus 3x. What you can do is you can break them into two fractions. So it becomes d over dx e to the power of 2x minus 3 over e to the power of 2 minus 3x minus e to the power of 1 minus x over e to the power of 2 minus 3x. And then you can apply the laws of indices. So same body and it is division. Then you can minus the power, which you get d over dx e to the power of 2x minus 3 minus 2 plus 3x minus. So for this, the second fraction, you apply the same approach, which you get e to the power of 1 minus x minus 2 plus 3x. Now you simplify the power, you get d over dx e to the power of 5x minus 5 minus e to the power of 2x minus 1. Then you can differentiate them separately. So this is what you get. Copy the same function e to the power of 5x minus 5, then multiply with the differentiation of the power, which you get 5, minus, for second exponent function, do the same thing, copy e to the power of 2x minus 1, then times with the differentiation of the power, which you get 2 here. So simplify, you get equals 5 e to the power of 5x minus 5 minus 2 e to the power of 2x minus 1. So how about E? So for E, you have no choice but to apply the quotient rule. So first identify the U. So the U here is e to the power of 2x minus 3. So du and v is e to the power of 2 minus 3x minus e to the power of 1 minus x. So du over dx will be 2e to the power of 2x minus 3, and dv over dx will be negative 3 e to the power of 2 minus 3x plus e to the power of 1 minus x. Then you can apply the quotient rule, d over dx e to the power of 2x minus 3 over e to the power of 2 minus 3x minus e to the power of 1 minus x equals e to the power of 2 minus 3x minus e to the power of 1 minus x, which is the v, times with du over dx, which is 2e to the power of 2x minus 3, minus u e to the power of 2x minus 3, and dv over dx is negative 3e 2 to the power of e to the power of 2 minus 3x plus e to the power of 1 minus x over v square, which is e to the power of 2 minus 3x minus e to the power of 1 minus x square. Then you simplify the expression, you get e to the power of 2e to the power of negative x negative 1 minus 2e to the power of x minus 2 plus e to the power of minus x minus 1 minus e to the power of x minus 2 over e to the power of 2 minus 3x minus e to the power of 1 minus x squared. So you can simplify again, right? It equals e to 3e to the power of negative x minus 1 minus 2e to the power of x minus 2 minus e to the power of x minus 2 over e to the power of 2 minus 3x minus e to the power of 1 minus x squared. This is the answer for E. Do you get all the answers correctly? Now, let's look at the application of differentiation of exponential functions. Here is the example. Given that y equals 3 to the power of 3x cosine x, find the value of x between 0 and pi over 2 for which y is a stationary. Here is the solution. From the equation given, y equals e to the power of 3x cosine x, we can see that there are two functions multiplied together, which is e to the power of 3x and cosine x. Hence, we need to use product rule, where e to the power of 3x is the u and cosine x is the v. Hence, dy over dx equals u dv over dx plus v du over dx. Hence, it becomes e to the power of 3x and dv over dx is negative sine x plus v, which is cosine x, then du over dx, which we get e to the power of 3x times 3. Then we can simplify. It becomes 3 times e to the power of 3x cosine x minus e to the power of 3x sine x. Then we factorize e to the power of 3x, bracket 3 cosine x minus sine x. Since it is given that it is a stationary point, then dy over dx equals 0, which means e to the power of 3x times 3 cosine x minus sine x equals 0. Hence, e to the power of 3x equals 0, or 3 cosine x minus sine x equals 0. However, e to the power of 3x equals 0 has no solution because for an exponential function, it is not possible to get 0. While for 3 cosine x minus sine x equals 0, we can rewrite the equation, which becomes sine x over cosine x equals 3, or tangent x equals 3. Hence, the value of x equals 1.25. We don't have to find the basic angle and then determine the quadrant because the range of the x is only between 0 to pi over 2, which means this is only in the first quadrant. And the value of x equals 1.25 has been rounded off to 3 significant figures. And this is the answer for this example. Now, you can try this example yourself. The equation of a curve is y equals e to the power of half x plus 1. Find the gradient of the normal to the curve at the point when x equals 0. You can pause the video and try to solve it yourself. Here is the solution. Given that y equals e to the power of half x plus 1, so dy over dx will be equals, copy the exponential function which is e to the power of half x plus 1, then we differentiate the power, which we get half. So we can simplify it becomes half e to the power of half x plus 1. Next, when x equal to 0, the gradient of the tangent will be mt equals half e to the power of half times 0 plus 1, which is e over 2. Then we know that the normal is perpendicular to the tangent, therefore mt times mn equals negative 1. So the gradient of normal mn will be negative 1 over mt, which is equals negative 2 over e. And the value will be negative 0.736. which has been rounded off to 3 significant figures. This is the answer for this example. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.